We're going to look at solving absolute value equations, and the absolute value equations are going to involve linear expressions and also quadratic expressions. The first type we're going to look at will be the linear expressions, so the linear absolute value equations. Before we start looking at these problems, make sure you understand how to solve, or the first step you're going to perform when solving an absolute value equation. So for example, we want to be able to solve this kind of equation. So the absolute value of 2x minus 1 is equal to 5. All right, so be careful. This is an absolute value equation. All right, now remember, this is not a linear equation. It's an absolute value equation. It involves a linear expression, but if you look at this, this is not a linear equation. It's an absolute value, okay? But what I want you to notice is that if you recall what absolute value is, so remember the absolute value is the distance that a number is from 0. So if we look at this, look at the absolute value of x is equal to 3, and I think about, well, what does that mean? Remember, the absolute value of x equal 3 means what is the distance that 3 is from 0. So if I look at negative 3, that distance is 3, right? And if we look at positive 3, that distance is 3. So there are two values of x, for which this distance is 3 units from 0. So this equation right here that I'm looking at, the absolute value of x equal 3, there are two solutions. So x equals a positive 3 and x equals a negative 3. What I want you to notice is that how I rewrote, and this is to be important when we look at this, how I rewrote this absolute value equation. So I wrote this absolute value equation into two linear equations. Okay, so that expression that's inside the absolute value bars is written on the left side, and notice that the number 3, I have 3 and its opposite. So you're always going to have its opposite on one side of the other equation. All right, so that takes us to this idea. If the absolute value of u is equal to a, then I can rewrite this into two different equations. U is equal to a, and u is equal to the opposite of a. All right, so that's how you're going to rewrite these. So if we go back to number 1, where we wanted to solve the absolute value of 2x minus 1 is equal to 5, so the first thing you're always going to do is you're going to rewrite this without the absolute value bars. Before you rewrite this without the absolute value bars, it's always important that you get the absolute value expression by itself. So notice it already is by itself. The 5 is on the other side. And so using this idea, I take the expression that's inside the absolute value bars, 2x minus 1, and I set it equal to 5. So notice basically the first thing you do is rewrite this without the absolute value bars, right? That's what it looks like. So I have this linear equation. So I'm writing this absolute value equation that involves a linear expression into two linear equations. And so the others, remember, you have to write two equations. So here's my first, and then the other one is the expression that's inside, just like you wrote here, 2x minus 1 equal the opposite of 5. And so the opposite of 5 is negative 5. And that goes back to this idea on the number line, 3, negative 3. Okay? All right. And so then you just solve each of those equations. And so we're going to add 1 to both sides. So remember, these are linear equations. So I get 2x equals 6, and divide both sides by 2. I get x to be 3. All right. Over here, add 1 to both sides. I get 2x equals a negative 4, right? Negative 5 and 1 is negative 4. Divide both sides by 2. I get x to be negative 2. All right. Now, let me just say this. If you're doing these steps correctly, and as long as this number right here is positive or 0, All right. So if you have the absolute value, if you have the absolute value expression by itself, and as long as that number on this side is positive or 0, okay, positive number or 0, then those are going to be your solutions. Now you can always check, okay, so you can always check though. So let's check, because you could have also made a mistake somewhere in this process. But if you do this correctly, then these will be solutions. So let's just check x equal 3. So always go back to the original. So the original is 2x minus 1, absolute value of 2x minus 1 equal 5. So in place of x, you substitute 3. So I get the absolute value of 2 times 3 minus 1. And then 2 times 3 is 6. So I get the absolute value of 6 minus 1. 6 minus 1 is 5. And the absolute value of 5 is 5, which is what I wanted. Okay? And you can do the same thing for negative 2. So if you want to check x equal negative 2, you do the same thing. So you go back to the original. The original was 2x, absolute value of 2x minus 1 is equal to 5. And in place of x, you substitute negative 2. So I get the absolute value of 2 times negative 2 minus 1. 2 times a negative 2 is a negative 4. The absolute value of negative 4 minus 1. Negative 4 and a negative 1 is a negative 5. And the absolute value of negative 5 is a positive 5. And that's what I wanted. Okay? All right, so those are your two solutions. Okay? So remember, always get the absolute value by itself before you split it into two equations. That's important. Okay, number 2. So number 2, we have this equation. So we have the absolute value of 2 minus 3x plus 5 is equal to 7. So the absolute value of 2 minus 3x plus 5 is equal to 7. Now always remember this. Before you split it up into two equations, before you use this idea right here, the absolute value expression has to be by itself. Okay? Notice it is not, because I have over here that 5. So I need to remove that 5. So I have to subtract 5 from both sides. That's the first thing you have to do. Once I subtract 5 from both sides, I get the absolute value of 2 minus 3x is equal to 7 minus 5 is 2. And now the absolute value expression is by itself, and so I can rewrite this into two separate equations. So remember, when you rewrite it without the absolute value bars. I want you to notice that you have this absolute value equation. The expression is linear, so you're going to rewrite this as two linear equations without absolute value bars. Okay? So you take what's inside the absolute value bars, that expression right here, 2 minus 3x, and you're going to set it equal to 2. Then you do the same thing. You're going to set 2 minus 3x equals to the opposite of 2. Remember that number line idea? That number line idea? So in this case it was 2, so you'd say 2, negative 2. Okay? And then you just solve each of those linear equations. So let's go ahead and subtract 2 from both sides. So 2 subtract 2 is 0. So I get negative 3x is equal to 0. Divide both sides by negative 3. And I get x to be 0. 0 divided by negative 3 is 0. So there's one of your solutions. Subtract 2 from this side. 2 subtract 2 is 0. So I get negative 3x is equal to a negative 4. Negative 2 to negative 2 is negative 4. Divide both sides by negative 3. I get x to be a positive 4/3. And go ahead and leave it as a fraction. All right, and again, you can check this, but it's not necessary because I do have an absolute value expression all by itself with this number on the other side being positive or 0. So as long as I did this correct, these are going to be your solutions. Okay, number 3. Number 3, I have negative 7 minus the absolute value of x plus 4 is equal to a negative 12. All right, now be careful. So remember, I kept telling you that if this number on this side is positive or 0, and you do this correct, then these will be your solutions. Okay, so you may say, well, that number's not positive or 0. Well, you got to be careful. Remember, you have to get the absolute value expression by itself first, which it is not. So there are several things you could do. One thing you have to be aware of is that that number, that operation right here is a subtraction. So you're subtracting an absolute value. So at some point, you got to be careful with this. It's not a, if this is plus, it'll be a lot easier. But a subtraction, so it's a little bit, you got to be a little bit more careful with this one. What most students will do is they'll probably add 7 to both sides, just like I'm doing. And then negative 7 and 7 is 0. So you get, though, be careful, you get 0 subtract, let me go ahead and write it. You get 0 subtract the absolute value of x plus 4 equal, and the negative 12 plus 7 is a negative 5, right? Okay, now look at this right here. 0 subtract absolute value of x plus 4 is the same thing as saying negative absolute value of x plus 4 is equal to negative 5. All right, now let's think about what I see here. So I want you to recognize, and this will be helpful. It is important you recognize this as written like this: negative 1 times the absolute value of x plus 4 is equal to negative 5, right? And so now, if I want to get this absolute value expression all by itself, see right here? Right now, multiplying by negative 1, the opposite is to divide by negative 1. So let me go ahead and rewrite this over. So I get negative 1 times absolute value of x plus 4 is equal to negative 5. So if I divide by both sides by negative 1, I get negative 1 divided by negative 1 is positive 1. So those divide out. So 1 times absolute value of x plus 4 is absolute value of x plus 4. See how simple that is? Equal negative 5 divided by a negative 1 is a positive 5. And so now I have the absolute value expression by itself, and I have a positive number on this side. And so now I'm going to rewrite this as 2 separate linear equations without the absolute value bars. So I get x plus 4 equal 5, x plus 4 equals negative 5. And then solving each of those linear equations, subtract 4 from both sides, I get x equal 5 minus 4 is 1. Over here, subtract 4 from both sides, I get x equal negative 5 and negative 4 is a negative 9. Okay, so as long as I did this process correct, these are your solutions. Okay, all right, now I just want to show you something. So you remember right here, if I go back to the original, I'm going to rewrite the original equation over. So some of you may have done this. I just want you to see that is definitely fine. So you see how we added 7 to both sides? What someone else might have done was this. So they would have said, well, I don't like that subtraction right here. So I'm going to bring this absolute value expression to the other side. And that's fine. You can do that. So you're going to add the absolute value of x plus 4. So you see right now you're subtracting, so you're going to add. But you got to do it to both sides, right? Just like this. And so when you combine like terms, the negative absolute value of x plus 4 and a positive absolute value of x plus 4, that's 0. So I get negative 7 equals a negative 12 plus absolute value of x plus 4. And now bringing this negative 12 to the other side, so I'm going to add 12 to both sides, just like this. I get negative 7 plus 12 is 5 equals, this is 0. And 0 plus the absolute value of x plus 4 is absolute value of x plus 4. And notice this right here, that is the same thing as this. So if you just transpose the sides, you get absolute value of x plus 4. Absolute value of x plus 4 is equal to 5. And so you just go from here. All right, so I just wanted you to see that just as you learned in previous courses and from all the years you've taken math, it does not matter whether you bring the absolute value expression on the other side or you keep it on that side. It does not matter. In the end, you will end up with that same absolute value equation that you're going to be solving. Okay, so that was number 3. So let's look at number 4. So there are some special cases that you may want to consider when looking at absolute value equations. So for example, we have the absolute value of 3x minus 7 is equal to 0. And so remember a while ago we said that if that number is positive or 0, and as long as I'm doing the process correct, then those will be my solutions. Okay, now this is 0 right here, right? So let's go ahead and start thinking about this like we were doing. So the absolute value expression's already by itself. And so I'm going to say 3x minus 7 is equal to 0. And then 3x minus 7 is equal to the opposite of 0, right? But isn't 0 and the opposite of 0 still 0? So this is redundant. That's not necessary. So this is not necessary, right? So necessary. So that's not necessary. So whenever you have 0 on this side, you just rewrite as one equation. So don't do two, because you're basically rewriting the same equation twice. So I'm just going to add 7 to both sides, and so you get 3x equals 7, and so divide both sides by 3. You get x to be 7/3. Okay? All right, so that's number 4. All right, number 5, we have the absolute value of 3x minus 7 this time is equal to a negative 2. Okay, now, so remember we always said this. We always said that, and let me go back to our original statement here. So when you have the absolute value of an expression equal a number, if this is a number right here, then that number needs to be positive or 0, right? So in this case, that number is negative. But remember, the absolute value of a number is always positive or 0. So if you look at this, I'm taking the absolute value of the expression. So no matter what value I put in for x, no matter what real number I substitute in for x, the absolute value of that number will either be positive or 0. It's never negative. So you see that since that's a negative on this side, you're going to say no solution. No solution. Because there is no real number that will make the absolute value of 3x minus 7 negative. So there's no real number that will make the absolute value of 3x minus 7 negative. Okay? None. The absolute value of a number is always positive or 0. Okay, so keep that in mind. All right? All right, now just to, and what some of you are going to do, some of you are not going to remember that. You're not going to remember that. And so if you go further, I just want to show you. So if you don't remember and you go further, this is what you're probably going to do. So you got to be careful. I'm hoping you recognize that whenever you get the absolute value expression by itself and that number is negative, you automatically say no solution. But if you did not and you didn't think about it, then you would have done this. You would have said 3x minus 7 equal negative 2, and then 3x minus 7 equals the opposite of negative 2, which is 2. That's what you would have said. Then going ahead and solving this, I want you to see, you get a 3x equal negative 2 and 7 is 5. Divide both sides by 3. You get x to be 5/3. 3 divided by 3 is 1. But you got to check. You have to check. So if I go back and I check x equal 5/3, into that original equation, which is this, the absolute value of 3x minus 7 equals a negative 2, look at what you get. You get the absolute value of 3 times 5/3 minus 7, right? 3 times 5/3, that's 5. So the absolute value of 5 minus 7. 5 minus 7 is a negative 2, right? And the absolute value of negative 2 is a positive 2, but 2 is not equal to negative 2. So x equal 5/3 is not a solution. Okay? No real number that you substitute into x will make the absolute value of this expression negative. Never. It's either going to be positive or 0. And if you do the same thing here, you'll get the same idea. So you'll get 3x equal 9, and so x will be 3. And again, if you check, you'll see that if you check x equal 3, you'll see it will not work. The absolute value of 3x minus 7 equal negative 2. So we see the value of x, substitute 3. You get 3 times 3, that's times, minus 7. 3 times 3 is 9. 9 minus 7 is 2, and the absolute value of 2 is 2, but 2 does not equal negative 2. So that's not a solution either. So So that's why you say no solution. All right, so just be careful. Don't waste your time doing all this when you could easily recognize that this right here had no solution, because you have the absolute value expression by itself, and you're saying that's equal to a negative number, which is not possible. Okay, so remember these little ideas. Okay, let's look at number 6. So number 6, I have this expression now. So we have negative 1 plus 2 times the absolute value of 2x plus 1 equal negative 5 times 2x plus 1, absolute value of 2x plus 1, plus 6. All right, now, so notice that you have absolute value bars on both sides, but the important thing I want you to recognize is that the expression that's inside the absolute value bars are the same. You have these two linear expressions, 2x plus 1. So it is very easy. It is very easy to get that absolute value expression by itself, to get it to look as the absolute value of u equal a. All right. So here's what we're going to do. So let's go ahead and first of all, let's add 1 to both sides. So just like this, and notice I'm aligning my like terms. So negative 1 plus 1 is 0. So I get 0. I'm just going to go ahead and write it out. 0 plus 2 times the absolute value of 2x plus 1 is equal to negative 5 times the absolute value of 2x plus 1 plus 6 and 1 is 7. Okay. Now 0 plus 2 times the absolute value of 2x plus 1 is 2 absolute value of 2x plus 1, right? I'm just going to go ahead and write it out just like this so we don't mess up. And now I'm going to bring this absolute value expression on this side. So I'm going to add 5 times the absolute value of 2x plus 1 to both sides, just like this. So I have 2 of these absolute value expressions, and I have 5 of these absolute value expressions. So together, I have 7 of them. So that's 7 times, so this becomes 7 times the absolute value of 2x plus 1 equal, this becomes 0, and you're left with 0 plus 7, which is 7. Okay? And then what I would do next is to get that absolute value. So you want to get that absolute value expression by itself, right? So you want to get this right here by itself. So right now I'm multiplying by 7. So the opposite would be to divide both sides by 7, just like that. 7 divided by 7 is 1. So 1 times the absolute value of 2x plus 1 is the absolute value of 2x plus 1 equal 7 divided by 7 is 1. And so now I have the absolute value expression all by itself. And notice this number is positive, right? So therefore, if you do these next two steps, or this little part here correctly, then those are going to be your solutions. Those will be your solutions. All right, so we're going to write 2 separate equations without the absolute value bars. I'm going to write, so since this is a linear expression in here, I'm going to write 2 linear equations without the absolute value bars. So 2x plus 1 equal 1, and 2x plus 1 equals the opposite of 1, negative 1. And then we're going to solve each of those linear equations. I'm going to subtract 1 from both sides. So I get 2x equal, this is 0, and this is 0 right here. 1 minus 1 is 0, so you got to put 0. Divide both sides by 2. I get x to be 0 divided by 2 is 0. So there's one of your solutions. Over here, subtract 1 from both sides. I get 2x equal a negative 1, and a negative 1 is a negative 2. Divide both sides by 2. I get x to be negative 1. All right? And so that's it. Those are your solutions. Okay, so that was number 6. So notice in the 6 problems we've done, when we got to this point right here, we had absolute value equations. When we got to this point, we had the absolute value expression by itself, but it was a linear expression. So let's look at a quadratic one. So let's look at a couple with quadratic. So let's look at number 7. So number 7, let's suppose number 7, we had this. The absolute value of x squared minus 3 is equal to 1. Okay, so first of all, notice the absolute value expression is already by itself, and this number is positive. So if I do all this work correct, then I should be good with the solutions. I do not have to check them. All right, so let's go ahead and do the process. So remember your two equations. Now this is quadratic, so you end up with two quadratic equations. Now, let me preface what I said. The right here, this is a absolute value equation. Okay, don't say this is a quadratic equation. It is not a quadratic equation. A quadratic equation does not involve absolute value bars. This is an absolute value equation, but when you rewrite it without the absolute value bars, it becomes a quadratic equation. All right, so you get x squared minus 3 equals 1, x squared minus 3 equals a negative 1. Okay? And then you just solve each of those quadratic equations. It's easy to get x squared by itself here. There's no x term, so the easiest way is to do this. So you get x squared equal 4. And then the best way to solve this quadratic equation is to take the square root of both sides, since there's no x term. But don't forget you get that plus or minus. Don't forget that plus or minus. So you get x to be plus or minus 2. Okay? All right, let's look at this one. So adding 4 to both sides, I get x squared to be, I'm sorry, I didn't mean 4. I meant 3, excuse me. Add 3 to both sides, right here. Add 3 to both sides. I get x squared to be negative 1 plus 3 is 2. Then let me go ahead and rewrite this. So to solve for x, we're going to use the square root property. I'm going to take the square root of both sides, plus or minus. So the square and the square root undo each other. So you get x equal plus or minus the square root of 2. And so notice, I want you to realize there are 4 solutions. So your solutions are 2, negative 2, the square root of 2, and minus the square root of 2. Okay? And that's it. That's all you do. And I just want to show you how to check this real quick. Let's do negative square root of 2. So those are your solutions, but remember what I'm doing is I just want to show you how to check this with one of the radicals. So let's just check x equal negative square root of 2. All right. So in place of your original equation, which is this, the absolute value of x squared minus 3 is equal to 1. So in place of x, we're going to substitute negative square root of 2. Now be careful. Since this is negative right here, we're going to put that in parentheses. So negative square root of 2 squared, because x squared, right? Then you got to subtract 3. And then don't forget the absolute value bars. And I want to see if that's going to equal 1. So remember what this means right here. This right here. Remember. Note. Negative square root of 2 squared means negative square root of 2 times itself. A negative times a negative is a positive. Square root of 2 times square root of 2 is square root of 4, which is 2. So this is 2 right here, right? So I get the absolute value of 2 minus 3. 2 minus 3 is a negative 1, so that becomes absolute value of negative 1. And the absolute value of negative 1 is 1, which equals 1. Okay? And so if you do the same thing for all of the others, this side will equal 1. Okay? All right. But remember, if you did all this work correct, as long as this number is positive or 0, did all this work correct, then these are your solutions, and you really do not need to check. All right, let's do 1 or 2 more with a quadratic expression. So let's look at number 8. Number 8. So number 8, let's say we had this one. We had x squared plus 7 equal 32. Okay. All right, so it kind of looks like number 7, right? Select number 7 right here. And by the way, so this right here, just to remind you about the terminology, these are all real numbers. These are all real numbers. 2 and negative 2 are rational numbers, and square root of 2 and negative square root of 2 are irrational numbers. Just to remind you about rational and irrational. See, these are. So I want you to note. Let me put that on here. Note 2, negative 2 are rational solutions, rational numbers. and square root of 2, negative square root of 2 are irrational numbers. Okay? All right, just to remind you about some terminology you've learned in the past. So if you look at this one, notice I have the absolute value expression by itself, the absolute value bars by itself. The expression inside is quadratic. This number right here is positive, so let's go ahead and separate them now. So I have x squared plus 7 equals 32. X squared plus 7 equals negative 32. Okay? So let's look at this quadratic equation right here. So I'm going to solve for, I'm going to get x squared by itself. So I'm going to subtract 7 from both sides. And so I get x squared equal, and then 32 subtract 7 will give you 25, right? Then let me go ahead and rewrite this over. Taking the square root of both sides, don't forget plus and minus. I get the x squared and the x squared and square root of x undo each other, so you get x equal plus or minus 5. Over here, subtract 7 from both sides. I get x squared equal negative 32 minus 7. So a negative 32 minus 7 is a negative 39, right? Now I want you to remember something. So if you take the square root of both sides, let me go ahead and rewrite this over. Take the square root of both sides. And remember the square and the square root undo each other, so you get x equal. Remember, you're taking the square root of a negative number, right? So the square root of a negative number is going to be imaginary. So I want you to remember that. Remember that from a previous course or a previous lesson that we've done. So that's imaginary. So remember that by definition, the square root of a negative 1 is defined to be the letter I. So the imaginary unit. So the square root of negative 39 is defined to be I square root of 39. Okay. Now, here's the point I want to make here. Depending on your textbook, depending on your particular book or the class that you're in, when solving absolute value equations, you will be asked usually just to find the real solutions. So in terms of real solutions, the real solutions are only these rational numbers here are only 5 and negative 5. These are not real numbers. Remember, imaginary number is not a real number. So if you're asked just to find the real solutions, then this equation here will give you only the real solutions. This one will give you imaginary solutions. So just keep that in mind, okay? All right, depending on your textbook or what program you're using, usually in almost most cases, when solving an absolute value equation, you will be asked to find the real solutions only. But you could also be asked to find all solutions, which would be the real and the imaginary. Okay, let's do one more. So this will be number 9. So in number 9, you have absolute value of x squared minus 5x is equal to, sorry, I forgot, this is not the one. So number 9, I apologize. Number 9, I want to use this one. The absolute value of x squared minus 4x, that's an x, minus 5 is equal to 7. Okay, so we have the absolute value expression by itself. The expression that's inside the absolute value bars is quadratic. This number on the other side is positive, so I'm going to go ahead and rewrite this without the absolute value bars. So I get x squared minus 4x minus 5 equals 7. And then x squared minus 4x minus 5 equals negative 7. 7, negative 7. Okay, so now remember in the previous problem, when we had this quadratic equation, the x term was not there. We had an x squared and a constant. Here we have the x term as well. So we have that linear term. So we're going to, in this case, subtract 7 from both sides. So I get x squared minus 4x. A negative 5 and a negative 7 is a negative 12 equals 0. And over here do the same thing. This time we're going to add 7 to both sides. So I get x squared minus 4x plus 2 equal 0. Okay? All right, so let's go ahead and solve this quadratic equation. Let's do the first one. And I think this one's factorable, so we can go ahead and factor this. We don't have to use the quadratic formula. So if I factor this, I get x minus 6, x plus 2 is equal to 0. And then if I set each factor equal to 0, just like this, I get x to be 6 and x to be negative 2. Okay? As long as I did this process correct, these are your solutions. You do not have to check. So remember, you don't have to check because this number right here, if you get the absolute value expression by itself, this number is positive. On this side, though, I am going to have to use the quadratic formula for that one because this is not factorable. So I will have to use quadratic formula. So let's see. A is the coefficient of x squared, so that's 1. B is the coefficient of x, which is negative 4. And C is your constant, which is 2. So remember the quadratic formula, the opposite of b, plus or minus the square root of b squared, minus 4ac, all divided by 2a, right? Okay, so we get x equal the opposite of b. So b is a negative 4. The opposite of negative 4 is a positive 4. Plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is 2, all divided by 2 times a, and a is 1. Simplifying the radicand, so remember this process is a prerequisite from other lessons that you've done and from a previous course. So you get 4 plus or minus the square root of negative 4 squared, 16. So you got to simplify that radicand first, which remember in the quadratic formula, this radicand is also called the discriminant. So we had 16. A negative 4 times 1 times 2 is a negative 8, all divided by 2, right? So we get 4 plus or minus the square root of 16 minus 8 is 8, divided by 2. And you will be asked to simplify the radicals. Remember, one of the things you've learned was simplify as much as possible. So let's see if we can simplify this radical. So the square root of 8 can be simplified because the largest perfect square that goes into 8 is 4. So I can write this as square root of 4 times square root of 2. 4 times 2 is 8. Square root of 4 is 2, so I get 2 square root of 2. So the square root of 8 I'm going to write as 2 square root of 2. So that becomes 4 plus or minus 2 square root of 2 divided by 2. And what I want you to notice is that all these, let me go ahead and rewrite this over so I can circle it. What I want you to notice is that these numbers here are all divisible by 2. So 4 divided by 2 is 2, plus or minus, and then 2 square root of 2 divided by 2 is just square root of 2. And so those are your other two solutions. So notice rational, rational, and then irrational because of that square root of 2. So you have 4 solutions altogether. So your solutions are all real numbers. They're all real, right? Oops, sorry. Solutions are 6, negative 2, 2 plus the square root of 2, and then 2 minus the square root of 2. So you have your 4 solutions. So these are all real numbers. So solutions are these 4. They're all real numbers. Remember the previous one, though, if you're just finding the real numbers, you only had these because this was imaginary. And by the way, I forgot, I'm glad I looked back at this. This is plus or minus right here, plus or minus. So this is plus or minus I square root of 39. So you had these 4 solutions, but only 2 are real. And usually they'll ask you for the real ones only when you're solving absolute value equations. So you have 4 real solutions. These are rational, and these 2 are irrational. Okay, just to remind you of some terminology from previous lessons or from previous courses. Okay, so I think that should help you with solving absolute value equations that involved linear expressions and quadratic expressions. All right, so that is going to be the end of this lesson on solving absolute value equations.